Hi, hello. Today we are going to discuss a 2016 question. In this question, okay, so two identical charge spheres suspended from the common point by two massless strings of length L are initially at a distance d apart because of their mutual repulsion. The charges begin to leak from the both sphere at a constant rate. As a result, the spheres approach each other. So with velocity v, then the v varies as a function of distance x between the spheres as okay. So here they have given two spheres and they are suspended charge spheres from the common point and continuously with constant rate these two spheres are discharging. When they are discharging, the separations are reducing, then the speed are also varies. And here they are asking what's the relation between v and this distance between the two sphere. Let's take so see the figure. It is the situation what they have given here, and this is a familiar method and already we have discussed about this one. So therefore directly we can take this as a tan theta is equal to a repulsive force between the two sphere. That's what it's a k q square divided by x square divided by okay, it is an mg. Then so we can easily define tan theta. If the angle is very small, what will happen? If the angle is very small, tan theta is equal to theta even, that is equal to sin theta. When theta is very small, sin theta is equal to theta, even tan theta is also theta. Instead of tan theta, even we can define sin theta. From this figure we just define sin theta. So just how do you define this sin theta? Opposite side divided by hypotenuse. Opposite side what they have given? It is x divided by 2 and hypotenuse side will be, it is L. So then that is equal to k q square by x square divided by mg. Then when you bring this x square into left hand side then it will what will happen here? It will becomes x cube, and remaining by keeping all the factors constant, so it is directly proportional to q square, or q square is directly proportional to x cube, or a q is directly proportional to, it is in raised to the power of 3 by 2. So now let's differentiate this. So when you differentiate this, because charge is disintegrating, therefore so when you differentiate this okay, dq by dt with constant rate, so is equal to, when you differentiate this with respect to time, so 3 by 2 x 3 by 2 minus 1 dx by dt. So therefore it will be sphere is discharging with a constant rate, therefore dq by dt will be constant anyhow. So dq by dt, then this 3 by 2 is also number constant x to the power of, so remaining what's remaining here, so it is 1 by 2 and dx by dt will be v. So this is constant, this is constant, only these two are variables. Then now they are related when I bring into left hand side, so v is directly proportional to x to the power of minus 1 by 2. So right answer will be first one. So next we'll go for next question to discuss the 2016 NEET or all over India pre-medical test. So look at the question what they are asked here. So an electric dipole is placed at an angle of 30 degree with an electric field intensity. It's 2 into 10 to the power of 5 Newton per coulomb. Okay, so theta will be 30 degree, and it experiences a torque is equal to torque they have given. Okay, the charge of the dipole length is 2 centimeter. So it's a very simple and a direct solution. So therefore torque 2 is equal to, so dipole moment, that's what a q into dipole length, it is a 2a, and p e sine theta. So therefore torque, how much they have given torque? Torque 2 is equal to, it is a 4 Newton meter, and the charge will be, so what we need to find out here? The charge upon dipole. So we need to find out charge only. Dipole length will be 2 into 10 to the power of minus 2, and what the electric field intensity they are given, it is an 2 into 10 to the power of plus 5, and the sine of 30 degree, it is 1 by 2. So therefore, so here 1, here 2, here 2 will get cancel. So remaining here 2 ones 2 2s, and q is equal to, so when I bring this, my here material of minus 2 is there, plus 3 is there, totally it will be plus 3. So therefore when I bring this into left hand side, then it will be 2 into 10 to the power of minus 3 coulomb. 2 into 10 to the power of minus 3 coulomb, 2 millicoulomb is the right answer. So now next let's go for 2017 question. Okay, here so they have given like this: suppose the charge of a proton and electron differ slightly. Okay, usually what will take charge on proton and charge on electron will take equal, but in this question they have given situation like this. So proton charge and electron charge are differ slightly. So one of them, so it's a minus e, it is a charge on electron, and other it will be e plus delta e, it is the charge on the proton, whatever it may be. So therefore if the net electrostatic force and gravitational force between the hydrogen atoms placed at a distance d apart is 0, the net net force, electrostatic force between the two hydrogen atom and gravitational force will become 0 at a distance d. Then we need to find out what is, okay, slightly different in charge, that's what delta E. Suppose here if you take an hydrogen atom are consisting of a positive charge nucleus and a negative electron. The charge on the electron will be minus, and the charge on the, it's in nucleus, what they have given, E plus delta E. Then what is the net charge on the hydrogen atom? It is what, E plus delta E and minus C, then that is equal to, so E plus E minus E will get cancelled, remaining delta E. This is the, so net charge on the hydrogen atom. Suppose if I take one more hydrogen atom, okay, so here also negatively charged electron and E plus delta E. Okay, the charge on nucleus and the distance between them, will take it as an d. Then what is the electrostatic force? Because net charge on this hydrogen atom, it will be delta E, even on this hydrogen atom also delta E. Therefore F E is equal to it is electrostatic force. It's 1 by 4 pi epsilon 0. It's a delta E into delta E divided by delta E divided by delta E into delta E divided by d square. Similarly, hydrogen atom will having a mass mh. Here they have given its value also. So mh. Therefore, the gravitational force between these two hydrogen atoms, so gravitational force, that's what G. It is m mass upon first hydrogen atom, mass upon second hydrogen atom, and the distance between those two hydrogen atoms from the centers. So therefore, so conditionally, so what they have given, so it's a electrostatic force is equal to gravitational force. What is an electrostatic force? It is a 1 by 4 pi epsilon 0 and delta E into delta E whole square divided by it is a d square. Then that is equal to, what about the gravitational force m? It is what G mh divided by it is a d square. Here d square will get cancelled. Now you know the value of this. So 9 into 10 to the power up 9 into 10 to the power up 9 into 10 to the power up plus 9, and remaining it's a delta E whole square. Okay, and that is equal to G into it's in mass of hydrogen, Okay, so then what's the remaining? So we need to know what is delta E. Okay, delta E whole square, then that is equal to G value. It's a 6.6 into 10 to the power of minus 11 into mass of an mass of an hydrogen atom. It is in 1.67 into 10 to the power of into 10 to the power of minus 27 into 1.67 into 10 to the power of minus 27 and all divided by it's a 9 into 10 to the power of plus 9. So therefore delta E whole square, then that is equal to, even if you not multiply all those values, just focus on the powers. Okay, let it be 6.6 into 1.67 into 1.67 divided by 9, so into, so minus 27 minus 27, it will be 54 minus 54 minus 54 minus 11, it is a 10 to the power of 54 11 65 minus 65, and here there is a 10 to the power of plus 9. When I bring into it into numerator, then it will be minus 9, then it will be 10 to the power of 65 10 to the power of minus 65 minus 9, then that's what delta E square, then that is equal to roughly when you take it okay, so then what will get 10 it is 10 to the power of, it is a 10 to the power of 60 74, yeah, it is a 74 minus 74, So delta E is equal to square root of 10 to the power of minus 74. It's a square root of, it is a half. So therefore 10 to the power of 74 by 2, it's around roughly minus 37, minus 37. Okay, so even sometimes you need not to solve accurately. Roughly you will simplify the powers, you will get the right answer. It's a very simple method, but it will take the time. That's it. Okay, you need to manage time sometimes. Next we'll go for the next question, the 2018 question. In 2018 they asked like this. Okay, in 2018 they asked like this: an electron falls from rest through a vertical distance height in a uniform and vertical up direction electric field. The field will be like this: vertical up direction electric field. And here what we are doing, so electrons fall from rest through a vertical distance h. So here we are dropping an electron to a vertical distance h. Okay, so then, so what the situation will be here? In a uniform vertical, it's okay. So in the electric field E, the direction of electric field is now reversed. Suppose the field direction is reversed like this. Okay, height will be same. Height will be same. So direction will be reversed. The direction of electric field is now is reversed, keeping magnitude same. The magnitude of electric field intensity is same. The proton is allowed now. So the proton is allowed in this case. So then, so falls from rest through vertical distance same height. The time fall of the electron in the comparison to the time fall of the proton. Okay, the situation will be like this: is they're asking, okay, so what is the time difference when with the same height, if the proton is fall or electron will fall, what may be the time difference? So now we know, so vertical height h is equal to, even from the kinematic equation, h is equal to half at square, and vertical height h and half, and whenever the charge particle which is enter into the uniform electric field, that will accelerate by like this: eq divided by m, okay, into t square. Now we need to know what is n t. So relation for t and m. So t square, then that is equal to, when I bring all these things, so 2h m divided by, what's the remaining, eq. So therefore t is a t. Okay, so t is directly proportional to square root of m. Okay, which is directly proportional, t is directly proportional to m. Since mass of proton is greater than mass of electron, the mass is, if the mass of proton is greater, so time taken is also greater. If the mass of an electron is lesser, so then time is also lesser. Therefore the relation of the proton with respect to electron, that will be, electron will takes a lesser time than the proton. This is the solution for this 2018 question. Okay, so next we will go for 2019 question. 2019 question. In 2019, what they asked, it was a very simple question. A hollow metal spheres of a radius uniformly charged and The electric field due to the sphere at a distance r from the center. So now you know basically how they are varying. If they are charged hollow sphere and it is very charged uniformly, and electric field at the center, it will be zero. The point inside the hollow sphere which is less than the its radius of the it is the radius of the hollow sphere, then the electric field intensity will be zero inside it, or 0 when distance of point which is less than the radius of the sphere. And then next what will happens, the electric field intensity gradually decreases, because you know the relation E is equal to 1 by 4 pi epsilon 0 q divided by r square, and its electric field intensity is decreases as distance increases. Okay, because E is inversely proportional to r square only if the distance of point which is greater than the radius of the sphere. The right answer will be this one. Next, and the last question, it is also simple and a different question they are asked in 2019. Okay, two parallel infinite line charges with a linear charge density plus lambda and minus lambda are placed at a distance 2r in a free space. What is the electric field at midway between two line charges? This is the case. Okay, so there are two parallel plates or conductors. Their linear charge density on each line charge, that will be plus lambda, and on another it will be minus lambda, and the distance between them, that will be 2r. Now we need to find out at midpoint between these two line charges. Now you know the electric field intensity at the midpoint of two charge plate. When you take at midpoint the electric field intensity, it is an E1. Because of this plate. So already we have proved by using Gauss theorem. That's what lambda divided by 2 pi epsilon 0 into r, and it is acting radially outward because this is positively charged, and because of the negative charge at this point, what will happen? That is what E2 will also acting in the same direction. So E1 at midpoint, E2 at the center, E1 and E2 are acting in the same direction. Because of negatively charged so lambda minus lambda, so electric field intensity E2 will be lambda divided by, it's a 2 pi epsilon 0 into r. So when it observe these two cases, magnitude of electric field intensity at midpoint, even because of this a linear charge or a plate, and because of this plate is also same, resultant of these two, if they are acting in the same direction, resultant will be E is equal to E1 plus E2. Therefore E is equal to E1 will be lambda divided by 2 pi epsilon 0 lambda plus lambda divided by 2 pi epsilon 0 lambda. Totally E is equal to 2 times of lambda divided by 2 epsilon 0. It is it's an r, it is r. So therefore here 2 will get cancelled. E is equal to lambda divided by pi epsilon 0 into small r capital R. Here we have taken capital R. we need to take capital R itself. Okay, it is a capital R. So lambda divided by pi epsilon 0 capital R. The right answer will be this one. Okay, so if you have any doubts and challenges, 100% you can WhatsApp me for this number 7892 186 108. Thank you.